Today we're going to talk about three different things. We're going to talk about basically risk analysis, developing an ergonomic process, and physical demand analysis. So in the hour and a half, we have a lot of things to cover, but we should have time at the end for questions. So when you walk away from here, we should be able to define the scope and practice of a board-certified ergonomist human factors professional, discuss essential components of a comprehensive ergonomic process, identify occupational ergonomic risk factors, identify personal ergonomic risk factors, and what we're going to talk about here is not going to be your typical awkward postures, force, contact stress, that stuff. Okay, we're going to talk about it in terms of evidence base. What does the evidence show? I spend about a quarter of my time as a forensic biomechanist, human factors professional, looking at injury causation and error. I've testified in over 75 state and federal cases on injury causation and human error. And so when I look at ergonomic risk factors, there has to be a basis for, yes, this activity could cause injury. So that's what I'm going to present today, is what does the research show? Because there's a lot of people out there going around talking about ergonomics, presenting it as, oh, this is an awkward posture, people are going to get hurt. Not necessarily. Okay, so we're going to talk about what does the evidence show. We're going to distinguish the difference between an ergonomic risk analysis and physical demand analysis. What I really want you to understand leaving here today is those are two completely different types of analysis. As a consumer, I want you to know what to ask for, okay? Because there are a lot of people out there that are not board certified. They've gone to a weekend course. Now I'm an ergonomist. They show up and they say, okay, you need an ergonomic analysis. They know one to do, and that's it, okay? There are thousands of ergonomic analysis that you can do, okay? Hopefully you'll leave here today understanding what the differences are. And if you ever have a question, call me up. I never charge for a phone call unless you're an attorney, all right? So call me up, ask me questions. I'm more than happy to point you in the right direction. Finally, discuss the application of physical demand analysis, return to work, and post-offer testing, which applies to this physical demand piece right here. And I have about 5 or 6 case studies at the end that we're going to discuss that goes over current case law. Some of them are literally as recent as a month old that talk about basically the case law, because that does change. And how that is going to be interpreted by the courts, you need to keep up on that to make sure that your physical demand analysis comply with the interpretations that are currently going on. So first of all, let's look at ergonomics. Ergonomics, or human factors, or user experience. Those three certifications are the exact same certification. Okay? Ergonomics, human factors, and user experience applies information about human behaviors, abilities, limitations, and the design of products, tools, machines, systems, tasks, jobs, environments for productive, safe, comfortable, effective, pleasurable human use. Okay, that's a technical definition. As far as ergonomics, these three up here are basically the exact same certification. There is a governing body that governs ergonomics internationally, the IEA, International Ergonomics Association. I'm saying that only because there are lots of companies out there that offer a weekend course that hand out a certificate at the end. They're not board certified ergonomists, okay? It's a 2-day workshop is what that is, okay? The BCPE is the United States board that governs board certified ergonomists and human factors professionals. Okay. The one thing I want to point out, most people when you think of ergonomics, and I travel about 80% of the time, I sit down on a plane, they ask, what do you do? I'm an ergonomist. I get, oh, you design chairs. Nope, never designed a chair in my life. Oh, you go into offices and look at carpal tunnel. Yeah, I do, but I don't do a lot of that. Okay. 89% of all board certified ergonomists have a PhD in psychology. Have a PhD in psychology, okay? We're going to talk today about the physical side over here, what most people think about when they think of ergonomics, okay? But the larger piece of ergonomics is actually this cognitive piece. Look at information processing, decision-making processes. I've testified in cases Was it appropriate for the officer to fire his weapon, use lethal force, police shootings? How is that ergonomics? Because you're looking at the decision-making process people go through, why people make decisions, how much time they have to process. Distracted driving, testified in cases regarding that. Labels and warnings. I have a case right now where a lady got scalped in a conveyor. Was it appropriately guarded and labeled? We're looking at anthropometrics, how much space was available for the person to get in, why the tray overfilled, why was she having to get in there to basically relieve the glue tray that was overfilling, and were the warnings appropriate to tell her that there was a hazard for entanglement. Okay? That's stuff that most people don't think about typically with ergonomics, but if you design products for consumer use, absolutely fits in there. Okay? The part of ergonomics that's really starting to expand right now is user interface. How you navigate through your cell phone. That's ergonomics. I have a good friend named David. He's the ergonomist for Apple. He's never been in an Apple plant in his life. Has never counted repetitions of how many repetitions it takes to make an iPhone. What he does, he designs what the swipe on the screen does, the double tap on the icon does. Okay? So does that give you a little better idea of the kind of the scope and breadth of the field? It's not just walking up and counting repetitions. It's really looking at the entire component from the cognitive side, how you interface with equipment or products, as well as the physical side. So if you're looking for an ergonomist, make sure you look for one that is board certified by the BCPE, okay? So my definition of ergonomics is designing tasks, products, equipment that fall within an individual's cognitive and physical ability, okay? So let's talk about developing an ergonomic process, not a program. What I'd like to start with first is there is no cookie cutter approach. When I go into a facility, the first question I ask is, what can you live with? What's going to work for you? Okay, how many people you want to make part of this team? Do you even need an ergonomic team? Because you know what? Honestly, I'd rather not have to manage an ergonomic team. I'd rather embed this process in a lean manufacturing team, in a Six Sigma team, in a continuous improvement team, because that's really where this process begins. How many of you need another meeting to go to and another team to manage? Yeah, no one does. So what can you live with? Now, how many people can you afford? If you can afford 2 people to be part of the team, you know what? Let's start with 2 people. Get the process rolling with 2 people, making something you can live with, and then we can build from there. I'd rather do that, start small and grow, than start with these big grand ideas that we know really can't sustain themselves in 6 months to a year, then it dwindles off, and you end up with nothing back where you started. So with ergonomics, I say, look at designing to improve human performance. And ergonomics is more than stretching, pre-work warm-ups, improving health or training. I'm not saying those are bad, but I go into a lot of companies, meet with them, and they say, what's your ergonomic process look like currently? What do you currently do with ergonomics? Say, we stretch before work. That's great. There's a place for that. What do you do for ergonomics? Okay. Well, we train people. Well, that's good. Everyone needs to be trained. Back in 2001, I was asked to develop the ergonomic process for the U.S. Postal Service. In 2001, it was the largest ergonomic process ever attempted in the world. Just the letter carriers alone that I was working with are over 275,000 letter carriers. So I had to design a process that worked in New York City, San Diego, California, and a small town in Montana. So I went to Washington, D.C., and I met with a guy named Larry Elia. Larry was the executive director for the ergonomic process for the Postal Service. He reported straight to the Postmaster General because back in 2001, the post office was spending millions and millions and millions of dollars on these musculoskeletal type injuries. And Congress mandated that they needed to do something to fix the problem. So I went and met with Larry in Washington, D.C., sat down across the table from him, and he asked me, Heidebrecht, what do you need to make this process work? Thought about it a second. Said, get me a mail bag, find me a letter carrier that's carried mail for 30 years or more, and I'll get back with you. So I carried mail for 6 months. In Albany, New York, I was teamed up with a letter carrier named Bill McCullough. And Bill taught me as much as he could about processing mail and carrying mail. I taught him as much as I could about ergonomics. I got chased by dogs, the whole thing, just because I needed to understand what they did. What are the tasks they had to do? One of the first things I thought I was going to do was redesign the mail bag. Every letter carrier you see is one shoulder hiked up higher than the other. Even at church on Sunday, they walk around like this with no mail bag. They just have one shoulder higher than the other. Why? Because these muscles are all so developed and tight. And so I thought, you know what? I'm going to redesign that mail bag. Get the bag down, get little pouches on the belt. Because every letter carrier every day has at least 3 different sorts of mail. What do I mean by that? They have what's sorted at the post office. That goes in one finger. And they have these mail sorting houses. So the credit card companies, the coupon people, they all sort their own mail. So the post office doesn't run that through the machines to sort it again. It comes in order of delivery. So they have 3 different trays that are all in order of delivery. So they have to separate them. So every house, they pull a letter from here, here, and here. Then they have their flats here on their forearm. So this is a posture the letter carrier works in all day long. It took me about 45 minutes to figure out this wasn't good. Okay, so, I'll get pouches down here so I could have the sorts of mail here. It'll free up the hands. So if I slip and fall, I can have 2 hands to correct and catch myself as opposed to just the one. It took me less than a week to figure out the mail bag was much more than for carrying mail. It's the first line of defense for dog bites. Every letter carrier is taught when you hear a dog, bring the bag off the shoulder, keep the bag between you and the dog. Mace is located right here, and you spray. So that first week, I was carrying mail. I heard my first dog. I remember that little nugget of information I got in training. Take the bag off the shoulder, keep the bag between you and the dog, and spray. The reason I tell that story is because I could have designed that mail bag, those pouches, that went around the waist. How many letter carriers would have used them? The ones that did, they have chewed up legs. So the point is, too many times in ergonomics, we buy things, we make things, we invent things for people. We walk up to them and say, here, take this, I made this for you. It's going to help you. The person takes it, looks at it, and say, what in the heck am I supposed to do with this? So they take it, sit it in the corner, collects dust for a couple weeks. Next thing you know, you're walking down on the shop floor and you see that thing that you spent all that time making and buying for them sitting in the corner collecting dust. What in the heck? We spent all this time and money making this for you. It's sitting in the corner collecting dust. And the person that you bought it for or made it for is like, what in the heck? You spent all that time and money buying me something that doesn't do what it needs to do. You have to involve the people that do the job in the process. Otherwise, you end up making things, designing things that don't fulfill all the needs of the product. Dog bites are a huge concern for post office. There are lots of jokes about it, but yeah, it's a big concern. They spend millions of dollars on dog bites. I've seen some nasty dog bites. So yeah, the bag needs to serve 2 purposes. It has to carry the mail, but it also has to prevent dog bites, or at least have a means of preventing a dog bite. So when I was working with the post office, one of the things that Bill and I noticed right away was that we could teach people how to lift properly. How many of you have been taught how to lift properly? Proper lifting technique. Yeah. You want to lift with your legs, not your back. Keep the load close to the body, chin up, lift slow, no jerking, all that stuff. You know the routine. It's important to teach people to lift properly. Let's take this a step further and say, you know what? Ergomark's going to come in, and I'm going to work with you. We're going to put the training together. We're going to do a train the trainer. We're going to come to every one of your facilities. We're going to teach every one of your individuals at your facility proper lifting technique. Every individual at your facility is going to demonstrate to me that they know how to lift properly. What's the chances one of those employees will either forget, not care, get in a hurry, next time you're out on the shop floor, you're picking up something like that? What are the chances? Guarantee it. 100%. I rarely use absolutes. I testify in court. I rarely use absolutes, but I guarantee someone will either forget, not care, get in a hurry, and use improper technique. So you can teach people how proper lifting technique, but the hazard itself is still there, right? You haven't done anything to eliminate the hazard. You just made someone aware of the hazard. And you've given them a tool to avoid the hazard. So in ergonomics, if you look at the true science of ergonomics, what you're really trying to do is design out the chance of human error. Design a process or a task so it's easy to be right, hard to be wrong. Design the task, there's only one way to do it, and that's the right way. So the first thing we did, Bill and I did, we found 4 mail tubs, we double stacked them, we duct taped them together. That was our lifting platform. When the mail handlers came in the morning to deliver mail to each case, they slid it right off the cart, right onto the little stand. The first lift in the morning was basically at knee level as opposed to off the floor. Is it perfect? No. Is it better? Yeah, it's better. That's something we could do at any post office. We did that around the country, did in Albany, New York. I worked in Albany, New York for a year and a half. Bill and I then went to San Diego, Oakland, California, Charlotte, North Carolina, Denver, Colorado, and did this throughout the country. That's something we could do that was visible right away. People could walk in the next morning, see things were up off the ground, so they could visually see a change, which is very important. When I look at ergonomic teams, I have very few guidelines as far as who needs to be on the team. I need a maintenance person on the team. I need a person that can make decisions on the team. And I have to have a communication chairperson. The communication chairperson is that most important person because they're the ones that take the pictures, they're the ones that document the changes, and they advertise the heck out of everything that we're doing because that's what starts the ball rolling. So we could do that at any facility we wanted to. Very quick, easy change. Designed to improve human performance. This is a tractor-trailer manufacturing facility that I worked with. And this facility, they make the yard dogs, the single cab units for pulling trailers, dock to dock, and that kind of stuff. Denny here has worked at this facility for 11 years. This is Denny here. This is a dash unit. His job is putting the firewall in, pulling some wire harnesses through, attaching some clips and some things like that. So at this facility, it's a lean manufacturing team that we're working with here. And so I trained them on ergonomic concepts. We're out looking at different opportunities. We see Denny. Does Denny look very comfortable? No. Sitting on a little stool, but he's kind of bent over. By the way, this is a can of aerosol spray glue. So about halfway through the day, I don't think Denny felt much pain at all, honestly. He's a little confined area that Denny's a pretty happy kind of guy afternoon. But anyway, Denny doesn't look very comfortable. So I walk up to Denny and say, there's probably a better way to do this. What ideas do you have? And Denny says, I've done this way for 11 years. Don't worry about me. I said, no, there's probably a better way. Haven't you, gone home a little fatigued and tired maybe on a Thursday night, dreading that Friday? So Denny stands up, walks over to the bench, draws up a little sketch. And we have a metal fabrication guy on the team. We have an engineer on the team. And it's kind of bounce ideas back off each other for about 5 minutes or so. The next day, Denny comes in, and he has a cart, looks like this. Now, I can look at this as an ergonomist. I can say, you know what, Denny's shoulder, it's a little higher than I want it to be. I'd like that shoulder down and relaxed. He's not standing completely straight up. He's bent over a little bit. The point is this at least better than that? Yeah, it's better. It's not perfect. The next cart we make, we're going to change the angle, we're going to change the height, we're going to improve on the design. The point is, we talked to the guy doing the job, improved on the process. Not only did we reduce the ergonomic risk for Denny, we took 7 minutes off the assembly time just by making that one change. We also identified that this had been a quality issue, or the root cause of a quality issue that they'd been dealing with for a long time. What was happening, you think later in the day Denny's arms were maybe a little tired from holding that firewall up? So he may not maybe apply that pressure quite as long as he did earlier in the day. So what was happening is these tractor trailers are going out, driving around on the bumpy docks and all that kind of stuff. Firewall started to fall down. When the firewall started to fall down, it pulled out the little metal clips. Then the customer had a brand new truck that had a rattle in the dash. Where to go back to? Getting Denny in a position where he's working with gravity, where he can actually see what he's working on, get to it easily. Quality issue went away. It took 7 minutes off assembly time and reduced the risk of injury. That's what an ergonomic process is about. It's not just about reducing risk of injury. It's increasing quality, increasing productivity, decreasing the risk of injury. Those three things go hand in hand. Designed to improve human performance and increasing efficiency and productivity. U.S. Post Office, Albany, New York. I've been working there for about 6 months. One of the guys over in vehicle maintenance came in, says, I need to talk to you guys. You need to come over to the shop. We do real work over there. All right. So Bill and I went over to the shop the next day. Just happens the day we show up, they're decommissioning a vehicle, which means they're getting ready to sell it in an auction. When they get ready to sell it in auction, they have to take all the markings on the vehicle off. So what he's basically doing is stripping off all the stripes. What's he using to do that with? Razor blade, yeah. Are you kidding me? He's given 3 days to decommission one vehicle. For 3 days, he uses a little window scraper razor blade and scrapes stickers off of the post office truck. So I went to his manager and I said, there's got to be a better way. This is a maintenance guy. He's mechanically inclined. He's a smart guy. Give him something else. Let him try something different. The response I got from the manager was, no, we don't have any money in the budget to buy anything. I'm not talking about buying anything. Surely you have something in the shop better than this. To this guy's defense, he showed up to work one day. They handed him a tool. He took the tool and did his job, right? So Bill and I said, you know what? We'll get your vehicle done in 3 days. If Bill and I have to go to Home Depot and pick up, or Lowe's and pick up our own little scraper, we'll do that. We'll get it done in 3 days, but let him try something else. So we come back the next morning to see how he's doing. He's using a high-pressure washer, a little bit of hot water. He'll right off. He was already on his second vehicle. Look a little faster, a little easier on the hands. It's not rocket science. But too many times we do things that way because why? It's the way it's always been done. It's a tool we've always used. Designed to improve human performance. It's reducing risk of injury, not simply, it's increasing quality, efficiency, and productivity. I do a lot of work in meat processing. I do all the ergonomics for Smithfield Foods, Johnsonville Sausage. I do a lot with Butterball Turkey, Land of Frost. I spend a lot of time in meat processing plants. Any meat processing or food production facilities here? No? Just as a side note, every type of industry is different. And so when I go into a food processing facility, the one person I ask for to make sure they're on the ergonomic team is someone in food safety. And I always get the response, why in the heck do you need someone from food safety on the ergonomic team? Because food safety is directly involved with ergonomics. First of all, if food safety isn't involved, I'm not getting anything done at that facility because food safety rules that facility. Any changes that are made they have to go through food safety to get approved. Second of all, rework, which is packages that leak, things like that. So it goes through a sealing machine. If it leaks, they have to rip the packaging off. Every additional handling of a product requires a touch by an individual. Every additional touch is a point of contamination. So if I want to get something done in a food processing plant, if I get food safety to understand ergonomics, they see the benefit, I can get anything pushed through and approved. So you have to look at who rules. Pharmaceutical industry, I do a lot with pharmaceuticals, same thing. Who rules that? Quality. So it's about what industry are you working in, and then who else in that facility has interest in ergonomic games, and then team up with that group. So food processing. This facility here, it's a bone-in ham facility. So it's a bone in the ham, and they're netting it. And so here in this process, this is a horn up here, netting's around it. This guy takes it, slides it across the table, stainless steel table, he yanks it back really quick because this is a quality issue. If you don't pull that netting back nice and tight, you don't end up with that nice little striping on the ham. It's a quality issue. That becomes your diced ham. Okay? You can make a lot more money off a nice looking ham with the netting that's properly fitted. So the plant superintendent comes to ergonomic team meeting. He says, I have a project for you guys. I have some people complaining of shoulder discomfort. Knock on wood. No injuries. But also, corporate's on me. We're not hitting our production numbers. This is bottleneck in the process. We might be able to make up some time here. Is that fair enough? So we go out and look at this person. So first of all, if you want to increase productivity, process right now. Ham comes down the horn, slides across the table, pulls it back, pulls that knitting tight, lifts it up to the clipper right here, clips it, puts a little metal clip around the end of it, cuts the netting, and then pushes it onto the conveyor where it goes around. A person takes it off, hangs it up on a tree to go into a smokehouse. So if you want to increase the productivity, what do you have to do? Decrease the number of steps, right? So we go out and look at this, and take some video clips, and we asked 2 of the people to do this job to come back. One of them spoke no English at all. The other one translated for him. Said, how would you do this job different? Got the look of deer in a headlight look? No. How would you do this different? So the guy didn't speak any English at all. Leans over to his buddy, whispers something to him. His buddy says, well, he was wondering, you could angle that table down. So the ham comes down the horn. Rather than sliding across the table and pulling it back, what do? Push it down the incline. So instead of using shoulder force to pull that netting tight, what are you using? Gravity. Nice thing about gravity, never breaks down. So we start to draw up on the whiteboard, a little sketch. And the other guy says, well, if you do that, why couldn't you angle the table towards the conveyor too? So now you go from slide across the table, pull it back, lift it to clip it, push it onto the conveyor, 4 steps, to ham comes down the horn, slides down the incline, lift it to clip it, and then what do? Let it go. Go from 4 steps to 2, reduce the stress on the shoulder, make the process more efficient. That's what ergonomics is about. A quality and productivity-based ergonomic process. The goal of an ergonomic process is to produce a higher quality product faster and safer. Ergonomics supports this by improving the processes that are used. When I look at an ergonomic process, I want to teach the people out on the shop floor to identify the opportunity, and then I want to work with you guys to figure out how to capture it. That is the most critical step right there. Most people understand ergonomic risks. It's not a mystery. They understand what an awkward posture is. They understand what extra force is. The problem is they don't have an easy way to capture it, because when line 2's down and people are bending over and twisting, are they going to stop and fill out an ergonomic form? No, they're going to get line 2 up and running. I've done this for over 20 years. I know I can make the form as simple as possible. They're not going to stop and fill out a form. They're going to get line 2 up and running. But if I can teach a couple of them to take a picture, or take a 5-second video clip, then have a shared drive that they upload it to on the facility, so that when the ergonomic team gets together, they get together, and rather than going out on the floor and walking around on the floor looking for stuff to do, they go to the shared folder, pull up the 5 opportunities that have already been identified, and fix them. It takes one person to identify an opportunity. It takes a team to fix it. What drives me absolutely crazy is going to a facility and having 13 people going out on the floor to look for something to do. The power of a team is creating change and brainstorming ideas. It takes one person to identify the opportunity. An ergonomic process becomes effective when ergonomic concepts are integrated into everyday activities. Don't make ergonomics about the meeting on the second Thursday of the month. Train your people to identify opportunities every day when they occur. Make a simple way for them to document those. If you have people on the floor that have the ability to have a cell phone with them, by all means, give them the ability to snap a photo, take a short video clip, then have a shared folder for them to put that information in. That step right there will lead to change. It must become how the company performs business. It must be integrated into what you do every day. It can't be a separate activity. If it's a separate activity, it's going to become a burden. If the process is a burden, it's not going to be sustainable. That's why I prefer to look, if you have an ergonomic team, that is great. If it's sustainable, that's great. But I almost would rather embed it into that quality improvement process, lean manufacturing process, because those are sustainable processes. Think outside the box. Like I said, group ergonomics with safety, quality, production, lean manufacturing, Six Sigma. So when I was carrying mail with the post office, there was an old grouchy letter carrier. His nickname was Yaz. And Yaz retired years before I ever even started going to Albany, New York. But Yaz always came into the office a couple times a month to give his buddies a hard time. And so he'd give me a hard time too. So one day I'm working at the post office, case and mail with Bill. And Yaz yells over, and he uses more colorful words than I'm going to use. He says, "Where the heck were you 20 years ago?" Like, I don't know, Yaz. Junior high, high school at that point. What's it to you? He goes, my grandkids came over this past weekend. My back hurt so bad, I couldn't go fishing with their grandson. Couldn't play with my granddaughter in the front yard. Flying back to Kansas City that Friday night, I got to think about what Yaz said. I can't think of anything more sad than work your entire life to get to retirement. By the time you get there, you're so beat up you can't actually enjoy doing the stuff you love to do. Whether it's fishing, hunting, riding your Harley, sewing, cooking, it doesn't matter what your passion is. So I made this my company mission statement, why I do what I do. Let's create a profitable workplace where all employees can reach retirement in a physical condition that enables them to enjoy it. That's what this is about. Profitable workplace. Workplace has to be profitable. If it's not, we don't have jobs. We need to find a way to produce the product, do the service, whatever it is that we do, in a way that doesn't beat our bodies up getting there. That's what the process is about. So, what we've talked about here is kind of that ergonomic process, what that looks like, or what I like that to look like at a facility. What we're going to talk about now is ergonomic risk factors. Okay? Any questions so far, though? All right, we'll jump into risk factors. So ergonomic risk analysis quantifies the presence of ergonomic risk factors in terms of magnitude, duration, frequency, in relation to potential development of musculoskeletal injury. So I've taught ergonomic risk analysis to ergonomic teams literally for 20 years. About 4 years ago, I kind of started questioning myself, and I said, when I'm preparing for a deposition or a trial or writing a report for injury causation, I go to several books. One is the NIOSH Yellow Book, free download. If anyone's interested in that, just shoot me an email. I'll send you the link. I still use it in court, and these will actually be up on the slides here in a little bit. It's still considered a gold standard. National Academy of Science published a book that basically reviewed the material from the Yellow Book from NIOSH in 2001. I was part of that committee and was a contributor to that report for the National Academy of Science. And then the AMA came out with guidelines on disease and injury causation in 2016. And I said, a lot of these ergonomic risk assessments, you have RULA and REBA and all these different assessments maybe some of you have heard about. They look at some pretty general things, but if you actually go to the peer-reviewed literature, There's nothing that actually shows that that risk factor has anything to do with causing that type of an injury. And so I started to kind of question, what are the true ergonomic risks? And so that's what I kind of want to walk through here. When you look at ergonomic risk factors, we have awkward postures, repetitive motion, sustained postures, contact stress, environmental conditions, and force. Most ergonomists agree those are the general ergonomic risk factors. And then you can add to that personal risk factors. And we're going to talk a little bit more about that later. The problem is a lot of people doing ergonomics that maybe aren't quite as trained will throw these up and say, these are bad, these are going to cause injury. They give you a checklist. You walk through the facility and you put a check mark by a box that says, well, is there an awkward posture? Well, sure. Check mark. I have to reach over here to do this. Well, do you have to exert force? Well, sure, we have to push this cart over here. Check box. Well, do you do repetition? Well, sure, we have 1,500 widgets that we make every day. Check mark. Before you know it, you're like, oh my goodness, how are people even walking out of here at the end of the day? I approach it a little bit different in that force. What do the astronauts on the International Space Station have to do every day to remain healthy? Exercise, yeah. Exercise, exert force. If they don't, what happens to their muscles and bones? Atrophy, they get weak. So this thing that we call a risk, actually, if we have too little of it, it has negative consequences too. When was the last time a physician said bed rest? You have to lay in bed for a week. When was the last time a physician said that? Hardly ever. Why? Because we know laying down, doing absolutely nothing is not good. Awkward postures. A couple years ago, my son broke his arm playing football. Had it cast at a neutral position. Doctor didn't cast it back like this or like this. Cast it in neutral position for 8 weeks. And he got it out of the cast. Was he able to just move that wrist around, no problem? No, it was really stiff. Why? He'd been in neutral position, ergonomically correct neutral position for 8 weeks. Those muscles literally shrank, and he lost his range of motion. So again, too little of an awkward posture has negative consequences. You lose your range of motion. What is stretching? Stretching is the most awkward posture you can be in. But we know stretching is good because it maintains normal movement. Okay, so the point is, I think it's a little too simple to throw these up on a screen and say these are risk factors, you have to avoid them. No. These are only risks when they occur with too much magnitude, duration, or frequency. That's when they become risks. By themselves, rarely does a single risk factor cause an injury. Rarely does a single risk factor cause an injury. That goes back to Denny, working at that tractor trailer manufacturing facility, where I said it doesn't have to be perfect, it just has to be better. You don't have to eliminate every ergonomic risk. I tell my teams, look for jobs where you have multiple risks. That's where your opportunity lies. There's a study done back in 1987 by Barbara Silverstein. Barbara Silverstein put together a study in Detroit with the big 3 auto manufacturers. And she had 900 people in this study. So this wasn't one of those studies that 4 guys over in the corner said this. This was 900 people, good statistically sound study. She analyzed the jobs, divided them up into 4 groups. She had a control group. Their jobs were analyzed. Their jobs basically had no ergonomic risk factors at all. She had another group. Their jobs were analyzed. Their jobs just had force, a single risk factor. A third group, just repetition. And then the 4th group, force and repetition both. The group with 1 risk factor, 1% of those individuals had a musculoskeletal injury. So it just shows it's not just what you do at work. Personal attributes have a very large effect on it. The group that just had force, 2.9, 3% of those people. The group that just had repetition, 2.7, basically 3% of those people. The group that had force and repetition, both 16.6, more than 5 times likely. So I look at this as a very positive thing because, like I said, it goes back to Denny. You don't have to make it perfect, you just have to make it better. Look for jobs where multiple risk factors exist. I'll take these odds any day. If I have a job that I can reduce the force on, but you know what? Repetitions, that's what we make. We make 1,500 a day. We can't reduce our productivity. But if we can reduce the force, we go from a 16.6 down to a 3% chance of an injury, I'll take those odds. So what is an awkward posture? I think there's a lot of misunderstanding with awkward postures. I have a lot of colleagues that talk about awkward postures and they say, well, awkward postures put additional stress on the wrist. Now, if you bend your wrist back, I have a master's in biomechanics. I can do this. I'll do it again. Okay? I'm not going to get hurt. My body's made to do this. Okay? The key with awkward postures require muscles to work in inefficient positions that result in fatigue. That's the key with awkward postures. It's not the position and the increased pressure on the wrist. That's negligible. It's the fact that you're going to fatigue a lot quicker. Everyone bring your hand up like this for me. Okay? Make a tight fist. All right, open that hand up, bend the wrist back, bend it forward, hold it in the forward position like this. Now make that tight fist. Difficult to do, isn't it? Neutral position, we have 100% of our grip strength. That's where we're strongest. At 45 degrees of flexion, we only have 60% of our grip strength. At 65 degrees of flexion, we only have 45% of our grip strength, less than half. That's the key with awkward postures. It's not this is going to cause an injury. It's the fact that I'm not strong in this position. So if I'm standing on a line with a straight knife, boning a ham, I have to bend my wrist, but I have to still hold on to the knife, those muscles are going to fatigue a lot faster and be prone to injury because of that awkward position, because I'm only working with 60 to 45% of that strength possible. That's the key with awkward postures. So what is awkward? Depends on the joint that you're talking about. There is no magic number. Okay? So for the wrist, we have a lot of motion going this direction, flexion and extension. This direction here, ulnar and radial deviation, we have much less. Okay, so you're going to have a larger window to stay in a neutral position in flexion and extension, whereas ulnar and radial, you're going to get to that awkward posture a lot faster because the window is going to be smaller. So the more motion a joint has, the larger that window to stay in a neutral position. The less movement a joint has, the smaller that window. Does that make sense to you guys? Sustained postures. Why are static or sustained postures so fatiguing? Well, when the body's at rest, you have very little blood flow that the muscle needs, so fatigue doesn't occur, and there's very little blood flow provided, so that's fine. With the dynamic contraction, where the muscle's contracting and relaxing, you have an increase in blood flow needed, but you also have an increase in blood flow because of the pumping of the muscle. That's how blood efficiently gets through the body. Contracting and relaxing the muscles as a pump. Now, with a static contraction, you have the muscle that's working, but is not pumping. So there's no increase in blood flow, so fatigue occurs very quickly. Just think about the last time you hung a shower curtain. Arms up overhead, put those little rings on, those little magnets in the bottom. Are they that heavy? No. It's that static contraction. Static, no pumping of the muscle, fatigue sets in very quickly. Forceful exertions. I want to talk about force. I want to talk about repetition together. Force, we're looking at basically exertion of moving something, exerting force, grasping something. With repetition, we're looking at performing the same motion with the same muscle group over and over again. All right, so I get questioned all the time by my attorneys when I'm being deposed or in court. So, Mr. Heidebrecht, how many repetitions are too many repetitions? How much force is too much force? Well, it depends. Depends on the muscle group that's being used. Small muscle groups, good at high repetition but low force. Large muscle groups, good at high force but low repetition. The key is matching the job task up to the right muscle group. Where you end up with fatigue and injury is where you pair up the wrong activity with the wrong muscle group. Okay, there are going to be job tasks out there that require us to exert force, or using the right muscle groups, large muscle groups, quads, biceps, deltoids. There are going to be job tasks out there that require us to perform high repetition. Are we using the right muscle groups for those? Small muscle groups, fingers, wrists, and forearms. Contact stress is the last ergonomic risk factor that we'll find in the workplace, really, and that's just contact between hard or sharp objects and soft tissue. So, environmental factors. With environmental, we just have heat, cold, whole body vibration, whole body and hand-arm vibration. We're not going to go into detail with those just for time's sake, but those are things that can if you have another risk factor present, they can exacerbate that risk factor. Heat, obviously, you have heat stress and things. I mean, yesterday and today, hot days outside, yeah, you have heat concerns with those types of things. Foundries, those types of things, yeah, you have to worry about heat. But in general, for most environments, these by themselves, with hand-arm vibration, I went to 3 days of the most boring 3 days of my entire life at the University of Cincinnati on an entire conference on vibration, okay? The takeaway from that, tool maintenance. That's a question on the board certification exam to become a board-certified ergonomist. Number one factor affecting hand-arm vibration is maintenance of the tool. When you purchase tools, they meet ANSI standards of not vibrating at frequencies that cause injuries. As tools are dropped, as grinding wheels become unbalanced, they start to vibrate at different frequencies. That could be frequencies that cause injury. So maintain the tool, maintain the tool, maintain the tool. Have a process in place to make sure your tools are being maintained. And I always tell my guys on the shop floor, if they're a metal fabrication facility and they're grinding welds and that kind of stuff, those guys know when the tool is working the way it should. If it feels funny, have a process in place to switch it out. Get it maintained. Whole body vibration. Fork trucks are going to be your biggest exposure unless you're a trucking company where you have over-the-road truck driving. Whole body vibration, the biggest exposure for the fork trucks is dock plates, driving over dock plates. I had a conversation with a client yesterday about this, and I'm actually a big fan of stand-ups. From a human factors perspective, you have a better field of view because those fork truck drivers, what do they spend most of their day doing? Sitting down, twisting, and looking backwards. Sitting increases disc compression force. Twisting increases disc compression force. And if you do that while you're driving over a dock plate, now you have a big jar. 3 risk factors present, right? Stand-ups at least neutralize the posture here, decrease disc compression force. Most of the stand-ups now you can get with floating docks. So you stand on them, and it actually cushions, but you also have your knees to absorb a lot of the shock. And I find that companies that go to stand-ups, they also end up with less struck-bys and run-intos because you can actually see where you're going a lot easier. So something just to think about. It doesn't work for all environments, but something just to think about. Personal risk factors, we have age, pregnancy, smoking, obesity, and diabetes. We'll talk a little bit about these in the next couple of slides when we look at that evidence-based stuff. But yes, personal risk factors do definitely come into play with musculoskeletal injuries. So what does the research say? This is that yellow book that I talked about. Published in '97, still considered gold standard. I cited it in a case for federal court just a month ago. Still accepted. Okay, if you're using a standard that's out to date, the judge is going to throw you out and not let you testify under Dahlberg. Still use it. And current research still supports the findings. The current research that's coming out still supports that. Nothing is being disputed there. So there is a table in the yellow book. And again, this is a free download on NIOSH's site. That actually goes through and shows, okay, for neck and shoulder, there is evidence that repetition has a contributing factor there. Peer-reviewed literature, okay? So there is evidence force, strong evidence of posture. Let's come on down to carpal tunnel. Evidence of repetition, evidence of force, insufficient evidence of posture. Interesting. What's the number one thing you hear about with carpal tunnel? Changing the posture. Insufficient evidence that shows that posture has an effect on carpal tunnel. Okay. There is evidence of vibration, although I believe that one actually is different. We'll look at this next slide up here and see. And then strong evidence of combination of risk factors. You can see over here, there's strong evidence here. Now, just because it says insufficient, the thing to keep in mind is there may not just be a study on it. Okay? And that these studies, in order to see if force is a contributing factor, that means that they had to conduct a study in which force was the only risk factor present. Does that make sense? Because you had two risk factors present, you don't know which one is contributing. So just because it says insufficient evidence doesn't necessarily mean that there is no causal effect there. It just means there may not be a research study. You have to look at the research and say, okay, yeah, there are studies, and it shows that, yeah, it's not an effect. Okay, great, we know that. But if it shows that there's no research done on it, then the verdict's still out. The second book, published in 2001, took that research, and this is the one I was a part of. I was asked to present to the National Academy of Science and basically present what do we know about the risk factors that are present and their contribution to injury. So what we did, we took all the research in the yellow book, and we created a little bit higher bar as far as what we're going to let in. A little higher standard from a statistical standpoint, and published it. But we came up and we found the same results of NIOSH book. We found no difference. And it is still also accepted in federal court as an authoritative text. This is the new book. Get it from AMA. It's actually a very, very good book. If you deal with a lot of work comp stuff out there, it's actually not a bad reference for you because it lays it out pretty simple. You can literally turn to the page on carpal tunnel and it goes through all the stuff and all the research on it and says what risk factors do we know are present that cause. We also goes through personal risk factors. So if you know a person maybe at your facility that has some type of a personal illness type of thing, you could also see, okay, is this tying into what we know about this individual and stuff. And I have been using this book very regularly for that. For consultation with clients as well. They'll call me up and say, hey, we got this job. This person got hurt doing this. Does this make sense? It's a great book to look at to see does it make sense or not. And I pulled just a couple things out of it. For carpal tunnel, for personal attributes, age, very strong evidence. Age is a contributing factor for carpal tunnel. BMI, strong evidence. Gender, strong evidence. Biopsychosocial factors, strong evidence. Diabetes, strong evidence. In fact, I've had 2 cases for clients that I've had thrown out because of diabetes and carpal tunnel, just since the first of the year. Comorbidity, strong evidence. Smoking, there is no evidence that smoking increases risk of carpal tunnel. Insufficient evidence for alcohol. Carpal tunnel wrist size, and this is just some of those personal attributes. There is some evidence is that as well. But this is kind of good stuff to know as far as personal risk factors. It does actually define what is repetitious for the hand. Cycle time of less than 30 seconds or more than 50% cycle time involved in performing fundamentally the same activity. What I find a lot of times is a lot of restrictions, and even a lot of people who go out and do ergonomic risk analysis don't necessarily understand what the true definitions of repetition is. A lot of doctors don't understand what the true definition of repetition is. I had a case for a large manufacturing facility that dealt with carpal tunnel that the doctor said, called it, well, he claimed it was work-related based upon high repetition. I actually did the analysis on it, and the repetitions were 10 times less than what would be considered repetitive. Wrote a letter and kindly informed the doctor that the job is not repetitive. High force for hands is 4 kilograms, so a little over 8 pounds. And then awkward postures of more than 45 degrees of wrist flexion or extension. Carpal tunnel, let me see, I went the wrong way there. Rotator cuff. Age, how many understand what the rotator cuff does? This is probably one of the most misunderstood, okay? Everyone stand up for me again, all right? Rotator cuff. So, first of all, there is not one ergonomic assessment out there that properly assesses risk of rotator cuff. Okay? In ergonomics, you hear a lot about awkward postures of the shoulder. You hear about elbows out, the chicken wing, right? You hear about reaching forward, and you hear about reaching back. Okay? None of those are rotator cuff. Rotator cuff is maybe a stabilizer in those, but it's not the primary motor. Okay? Rotator cuff. Everyone put your elbow right at your side. Bring your other arm around, right back here. Keep your elbow at your side, and do this. Feel those muscles back there? That's rotator cuff. Rotating the humerus. This is rotator cuff right here. Rotating the humerus. So, any assembly line job, right? Rotator cuff. Where are my elbows? Right by my side. No ergonomic assessment out there is going to identify that as a potential injury for the shoulder. This is a total rotator cuff movement. Okay? So any movement on an assembly line where product is going by is rotator cuff. Pushing overhead, rotator cuff. Pulling, crossed, rotator cuff. Those are rotator cuff movements where the arm, the humerus is rotating around the shoulder. That makes sense to everyone? I have colleagues of mine that talk about, oh, don't hurt the rotator cuff. Oh, I won't. That's not using the rotator cuff. Okay? This is rotator cuff. Okay, you guys can sit down now. So, again, we got some occupational risk factors, some evidence, combination, highly repetitive work alone, some evidence there. Awkward part, the most thing with the shoulder is looking at flexion of greater than 60 degrees. Okay, so it's that forward here and elbows out. And for the back, strong evidence of no association with age. I found that very interesting. Very interesting. BMI, insufficient or conflicting evidence. History of back pain, strong evidence. Insufficient with sleep. No association with exercise and leisure. All right, so I threw this up here just because I wanted to kind of give you an idea of how I approach a risk assessment at a facility. In that most ergonomic assessments analyze the whole body. Rarely do we have a musculoskeletal injury of the body from overuse, that type of stuff. It occurs to the shoulder, the wrist, the elbow, those types of things. And so the way I approach it, and you can't see it very well, but I basically list the observations, the things that we know from those texts that I just went through. Okay, what do we know has a contributing factor to this injury, and then what body part is it associated with? And then I group it by body part, and I tell the individuals, you will have check marks by a body part. I expect that. No one is going to stand at work and do this all day, right? You will have check marks. But when you start to see clusters of yeses on the same body part, that tells you there's additional stress on that body part. You have multiple risk factors. And when you have multiple risk factors, risk goes up. So I look at risk by body part as opposed to whole body. That's what I would suggest you guys kind of start to do, is look at it by body part, because you're not going to injure your body with a musculoskeletal injury. You're going to have a shoulder injury. Well, what factors affect the shoulder, and do we have a cluster of yeses there? If so, then yeah, there's a lot of stress on the shoulder. Let's focus on reducing that risk on the shoulder. I also divided up for the shoulder by left and right. Most assessments out there just ask about shoulder repetition, and you lump repetition together for left and right. Well, I can tell you there's a lot difference between doing 10 repetitions here and 10 repetitions here, or 20 repetitions with my right. Okay, so I also recommend dividing it out by body part where you have 2 body parts, because that'll show if you're stressing one side of the body more. It could be simple as, you know what? You need to rotate sides of the line. It's a simple fix. Okay, but people get comfortable standing in their spot, so they always work on their side of the line, so every repetition is to that right. All right, so any questions on ergonomic risk factors? Did I blow through that too fast for you? You learned something? Okay. So let's talk about return to work and post-offer testing. So what we've done, we've talked about physical, we talked about risk analysis, now physical demand. With physical demand analysis, you're analyzing the job as it exists today without quantifying risk. And that is very important. Okay? Don't create a liability for yourself you don't need. Okay? Your risk analysis is where you quantify risk. Your physical demand analysis, this is the document. Oh, let me hop back here. This is the document that you're going to send out to your therapist, to your physicians, people like that for return to work, for hiring protocols, those types of things. Okay? You don't need to associate risk in there and air out all of your dirty laundry if you don't have to. Does that make sense? Okay? I'll walk through some examples of that, but a NIOSH lifting equation is an ergonomic risk analysis for lifting tasks. That's a risk assessment tool. I see all the time where a physical therapist or someone has come in, done an ergonomic analysis and created a physical demand report and used the NIOSH lifting equation in that physical demand report. You've now quantified the risk. If there's any question at all whether the work-relatedness of the injury was there, you made the decision very easy for the physician now because you just laid out all the risk associated with it. Okay? So it does not quantify risk of injury. It documents the job in terms of posture, force, duration, endurance requirements. A lot of times as a professional, you're asked, what are the physical requirements of the job? And you get the phone call from the therapist or from the physician and says, well, or maybe your boss is saying, well, or the supervisor of the individual, well, can the person go back to job? What jobs can they perform? Can we accommodate the individual? Okay, those are the questions you get, and you feel like you're looking into this crystal ball that you don't have any information on. You're just supposed to visually see, can they go back and do this job safely or not? And you don't have the information to make that decision. That's where the physical demand analysis comes in. That will tell you what the physical requirements of the job are. The physician and therapist tell you what the physical requirements of the individual are. You can very easily see if those match or not. The do's and don'ts of physical demand reports. So very quickly, I'm just going to kind of go through here. This is an example of a physical demand report, but this person, this therapist, actually wrote, for the spine, structural stresses, well, I'm not going to use the word stresses. First of all, in my ergonomic reports, I don't use the word risk either. Okay, I list everything as an opportunity. If there's something that, and I had a conversation last week with a client, there was a hazard that needed to be fixed. I didn't put it in writing. It was a phone conversation that we had. Okay, why? If I put it in writing, you're aware, you do nothing about it. If OSHA walks in and you have plans to do something about it, you're still liable under the general duty clause because you're aware of it, haven't done anything about it yet. So I'm not going to put you in a situation that basically you're aware of a hazard and don't have time to do anything about it. We'll have a conversation about it. I can write up a report. We'll talk about the language, but I'm not going to put you in a situation that creates a liability. Okay? So for this one, they wrote, significant loading of the spine structures are likely in this position. Forward flex postures require no activity from the torso musculature, but increase asymmetrical disc compression, blah, blah, blah. Basically, they're saying the back is at high risk of injury. Okay? That's not what's needed in this report. We need to understand what the back is required to do so we can test the individual, see if they can do the job. We don't need to identify the risk. That goes in a different report. Never, rare, infrequent, occasional, frequent, constant. So first of all, DOT, not the Department of Transportation, the Dictionary of Occupational Titles. How many of you are familiar with the Dictionary of Occupational Titles, DOT? Yes, okay. They set the standard back in the 70s as far as the phrasing that is used to quantify jobs for the Social Security Administration. Never, occasional, frequent, constant are the 4 terms that are used. Okay? Infrequent and rare are not terms used by the DOT. Don't make up stuff. Use terms that are part of a standardized process, the DOT. If you need information on that, shoot me an email. I can send you all the documentation for that. I printed this report off this year. It was done in 2004. Keep your physical demands up to date. Okay? Keep your physical demands up to date. Before you analyze a job, you must first quantify what you're doing. And so, about 5 years ago, I started a process with my business partner, and we began a journey. We started to look through the peer-reviewed literature and say, what does the research say? Because I see lots of physical demand analysis done out there. But I see a lot of variation how they're done. I see a lot of people doing analysis, and I ask them, well, so what's your definition of standing? Well, it's staying in one spot. What's your definition of walking? Well, it's moving. Okay, well, if I stand in a conveyor, and every 10 parts, I do this. Is that a walk? It's 10 people, you get 10 different answers. If I stand in a conveyor and I do this, is that a walk? It's 10 different people, get 10 different answers. Okay, so what we did, we actually went through, we have over 443 articles that we reviewed over the past 5 years. I'm actually flying to England tomorrow to present at the International Physical Employment Standards Conference about this study. 434 articles that we reviewed. It's a living document, so as new research comes out, we update it. And what we found was there are definitions out there. A lot of people just don't know them or use them, or they choose to make up their own. And so we could have made up our own definitions, but we said, okay, let's look at the research. And what we found was walking, there is a definition. Walking is taking 3 steps or more. Standing is taking less than 3 steps. Good, now we have a standard way to analyze the job every time. Lifting is 5 pounds or more. So now we have a standard as far as what is lifting. Okay? We also visually document the job. So, and this is just one way you can do it. I did this for years and years and years manually. With an Excel spreadsheet and Word. We actually made a software program that makes it very simple to do, but you just pull the video clip that you capture on your phone up. You do it. When you want to capture it, you pause it. Pull down your little screens here, capture the physical demands as far as frequency, duration, repetitions. Produces the report then that basically captures not just one column that says what the DOT level is, which most reports do, occasional, frequent, constant. I've had 3 cases this year alone where employers have been challenged on their post-offer testing protocols. And in all 3 cases, the therapists that did the reports cannot go back and show where the physical demand was required in the test protocol. And all 3 cases, the company lost because they didn't have the documentation they needed to back up the test they were doing for hiring. Occasional, frequent, constant is automatically calculated with your duration and frequency. And then I have duration without recovery. I think that's one of the most important things that isn't captured is the endurance component. How long does this person have to use their arm? How long do they have to reach without a break? Because that tells the therapist and the physician that endurance component they're going to need. So we have, for all your different physical demands, lifting, handling, manipulation. Interesting thing, our handling manipulation, most people think, I started with the occupational therapy, hand therapist, to define the different pinches and grasps. I found the research in robotics. Engineer robotics, because they're mimicking what the hand does. So they've actually gone through and defined all the different pinches and grasps that the hand does. And that's where I found the research to document the different types of grasps and pinches. Sensations, just real quickly. A lot of people don't think about this sensation piece of it. Every meat processing plant I work in, maintenance individuals have to do a smell test for ammonia detection. That's your only warning system in ammonia is smell. So if your maintenance guy can't smell, you can walk into an environment that's going to be very hazardous. And so same with natural gas. If you have a facility where a maintenance guy is working with natural gas and stuff, again, that is the warning system for natural gas is smell. So those are little things to think about that a lot of people don't think about. Electricians and color. Very important. You don't mix up red and green sometimes. And then every one of those physical demands has a photo tied to it. I think visual documentation is key because this shows exactly the posture they work in, the environment they work in, and the activity they're performing. I've never had one of these questioned in court. I've had people go to their attorneys, and the attorneys say you don't have a case. You've documented the essential functions of the job. You've quantified it in terms that justify the test protocol. So, how is that used? That basically is your validity component for your return to work and your post-offer testing protocol. That's what this document is used for. Okay? So just like with this here, I'm very functional in my test protocol development. I'm going to go through very quickly a functional test or a legal case that I think is 2 to 3 months old. CSX Rail had a $3 million lawsuit just a couple months ago for doing a test protocol with isokinetic testing, which is basically your machines out there that you use, the big machines you go to therapy and you go through and do the testing, is not functional based. If a person has to squat or stand, I want to see them squat or stand. If they have to lie down on the floor and weld, I'm going to have them lay down on the floor, hold a 25-pound weight, and act like they're grinding for me. That tells me a lot. There's a lot of information that goes into getting down onto the floor in this position and being able to get up out of that position that tells me if they're going to be able to do that job safely. I don't want to have to do a test. There's other tests out there that are basically isometric where you like pull on a bar and then based on that, the amount of force you exerted tells you if you can do the job or not. If I have to do math in court, it's not going to be a good day. Okay, I don't want to have to extrapolate out how this test relates to if they can lay down or not. Okay? So basically, this report here, your physical demand report, then creates your test protocol. This is just an example that I threw up of one that I create, that the software does. Your test protocol, but then every test has a written protocol. Why? Because therapy clinics, someone comes in, you teach someone how to do it, the new person comes in, they change the process. Before you know it, you have a test protocol that didn't resemble anything like what you had intended it to be. Every test is standardized and written down so you get consistency. I replicate postures. This is a roofing company test that I put together. Get them on incline, have them kneel down, and work. Why? Because that's the job they're going to have to do at the job site. So just real quickly, a couple case studies. So we're working with a foundry. and had an individual with a stroke. Personal physician released him back to full duty. How many of that's happened to you guys? Personal physician has absolutely zero clue what the guy does at work, right? But yep, he can do his job. Why? Because he delivered the person? I don't know. But I mean, yeah, there's absolutely no justification for it. Company had a policy in place. I recommend with all my companies, you have a policy in place that if they're off work for X amount of time, they have to go back and be retested as long as the injury, illness is in relation to the type of job that they do, which usually you can justify based off of endurance and those types of things. There are very few times in an employee's employment you have the ability to test them to make sure they can physically do what they do. When you hire them, and then when they return back from an injury or an illness, work-related or non-work-related. And what we do is we put together a policy that just states, if you're off work for X amount of time, you have to go through the post-offer test protocol again. This individual came back, was unable to complete the test protocol, failed dramatically. He had a stroke. He had balance issues, lots of things going on. He shouldn't have been in a foundry up on elevated equipment. Company physician called the personal physician. I produced the report for the physical demands of the job to the personal physician. Company physician went over it with him with the test protocol and the results. Personal physician agreed, reversed his opinion. Company physician, personal physician wrote a letter to Social Security, got him onto Social Security using the report showing that he didn't have the ability to do basically his job tasks anymore, and got him straight onto Social Security without touching the company's disability plan. That's how the process is supposed to work. It ended up in the best position for the person doing the job. He couldn't do his job anymore, his trade. He couldn't weld. At a U.S. government organization that I'll not name to protect the guilty, that 15 years ago had an individual who had a stroke. Person came back to work 15 years ago, and they said, you know what? Don't worry about doing that part of the job. We'll just have you work over here in the mailroom. And hey, don't worry about doing that over there. And hey, you don't have to carry that, because he didn't have use of the right side of his body. Well, last year, with budget cuts, this government organization said, we need more people to do this, and he can't do his job, so we're going to fire him. Now, for 15 years, you've accommodated Wade. 15 years. You can't fire him after accommodating him for 15 years. You've definitely set precedents. So I had to have that conversation. That's a common thing that occurs in a company, in that, oh, come back, you think you're being nice, okay? But by doing that, you're basically saying whatever they aren't doing is no longer an essential function of the job. And you do that a couple of times, you end up with a facility that has a bunch of watered-down jobs with no essential functions that you have no ability to deny anyone employment for. So anytime a person goes through a functional test and they fail, I tell the therapy group to call me up. I want to know. Because I want to make sure that we hire everyone that can physically do the job and we deny employment to whoever can't. So we had an individual at a rail company that doing maintenance away work out on the track, hard physical work. A female applicant. Okay, and so this is a primarily male-dominated industry, so from an EEO standpoint, it was we really wanted to be able to hire this person, but we really couldn't change the job for this person. But if they could do the work, we wanted to hire them. She went through the test protocol. Grip strength. She passed the first grip strength at 65 pounds. I had 3 grip strengths in a row at 65. Passed the first one. Second one, she barely got, struggled but got. The third one, she did not get. So she had 3 tests. She passed 2, failed the last one. Therapist called me up, she passed everything else fine, just the grip strength. Went back and looked at the physical demand report and said, you know, I'm probably make the test better, because nowhere in the job did she have to do 3 maximal exertions right in a row. There's recovery time built in. So I changed the test protocol for a 1 rep max, but then I made an endurance grip where she had to hold 25 pounds for a minute. She passed fine 9 months ago, hasn't had an injury since. 2 months after that, had a male employee come in that could not grip 65 pounds. We denied employment to them, okay, because you do have to be able to grip 65 pounds. Okay, but that's a situation where we looked at the test protocol, looked at the physical demands of the job, and improved upon the test. Everyone after that point now does a 1 grip max instead of a 3 and does an endurance grip. As long as you're consistent in how you do it, you can make those changes. Johnsonville Sausage had an employee, we're wrapping up here, had an employee at Johnsonville Sausage. Any meat processing plant that I work with, I do a balance, or foundry, anywhere working on ladders, elevated platforms, do a balance test. And had an individual that failed the balance test. And why? Because you're working in a slick environment where a fall can occur. So the person failed the balance test. I called up Moments, Illinois, where the Johnsonville factory was. And I talked to the trainer that I know at Johnsonville. We have a process in place there where whenever they offer a job to someone, they take him out on the floor and do a tour because they want to make sure they want to work in that type of environment. I said, what was your general impression of this person as they're doing the tour? I was scared to death they're going to fall down and hurt themselves. Perfect. The balance test worked and did exactly what it was supposed to. This is where the CSX study just released earlier, about 3 months ago, for isokinetic testing because it wasn't task specific. They went through a basic protocol where they had them exert weights and twist and things like that. It was not functional based. It was basically just testing strength on a machine. And then this one just came out June of this year, and the firefighter test for Canada. And this one, this group is actually going to be presenting in England Monday at this conference I'm going to, so I'm interested to see, because it is a very functional test. All right, so in summary, develop an ergonomic process you can live with. Okay, I'd much rather start small and grow, start big and have it fail. Integrate ergonomics in activities you already perform. Use an evidence-based approach for identifying ergonomic risk and causation of injuries and for hiring. Hire the right people and then keep them healthy and injury-free. Create a profitable workplace where all employees can reach retirement in a physical condition that enables them to enjoy it. With that, I am done. Like I said, I never charge for a phone call unless you're an attorney. So I welcome any phone call. I've been self-employed since 1998. I'm in Kansas City, so I don't have to hop on a plane to go anywhere. It's an easy drive. If you ever have a question at all, please call me up. 99% of the time, I can answer the question with a scan of a book and an email or talking to you for 15 or 20 minutes. So don't ever hesitate to give me a shout. I mean that sincerely, okay? It's been a pleasure talking to you guys, and it's been a pleasure working with Connell as well. We're going to be having some conversations with them, and for any Connell, I guess, customers, you'll get a discount off of the price of any consulting or anything that you do, online training, all that kind of stuff. So I appreciate your time. Thank you very much.